So I'm from a little country called Norway, and a part of University of Agder. And I cooperate with a local theme park, and together we want to figure out how we can use AI to understand our market a little better. And that is what inspired this project. So the project is Synthetic Personas, enhancing demographic response simulation through LLMs and genetic algorithms. So my name is Morten and I'm the author of this paper, and I got the guidance from Arne Andersen and Morten Goodwin. All right, so in this presentation, I will talk a bit about the problem I'm trying to solve, so we understand why this is an important problem and how we can work towards our goals. I will talk about the methodology so you can replicate my results. I will go through some experiments we have done on this and the results we've gotten, and this is part of our ongoing work, so my plan is to continue working on this and release more papers. So we had some limitations in this one, and we're trying to fix those for the next ones. And I will talk a bit about the future work and what we can learn from this paper. So what are we trying to solve? Well, we're trying to understand the market a bit better. And literature shows that most projects that goes to market and fails and under-delivers in sale is because the different companies hasn't done the market research well enough. So I talked to some people that was producing a movie in Norway a couple of days ago. And when they produced the movie, it didn't do well in the cinemas. And they were wondering if it was because they hadn't reached the target demographic, or if the target demographic didn't go to the cinema. So doing market research is very important in order to get a good results when doing anything. So what can you do? Well, you have a lot of traditional methods, so surveys, focus groups, and so forth. They all have their limitations, and the typical share those limitations. So one of the limitations that is reported in literature and different studies is that it's very difficult to get people to respond to your surveys. So depending on the method you're using, you can expect 5 or 30% to respond to your surveys, but not much more. And if you're using methods like sending mass amount of emails, you will get probably lower response rates than these. It costs a lot to make a survey. So you have to design it and you have to be clever about it, because people have an attention span about 10 minutes. Paper says that if you exceed these 10 minutes, people will start just skipping through your survey, and you will get lower quality surveys, and you will often have people falling out in the middle of the survey. So you have a very short time, a very short amount of questions you can answer in a survey. You also have to think about this setting, which you're trying to get the results from, because if you are face-to-face to someone and start asking questions, you will get different responses compared to if you just send an email and try to get someone to respond there. So it takes a lot of time is the other factor. So you have to have a phase where you design it, and then you have to send it out to different people, and then you will get responses eventually, and then you have to do analysis. And this usually takes around several weeks to some months. And the problem is that a lot of different projects want to get started right away. So waiting several months before you do anything, it's kind of a waste of time. And often when you do different types of survey, you end up wanting to ask new questions, learn more about the interesting things you find in it. And you have to do the process again. And for example, with my working with the theme park, we find that the surveys we are working with have a very limited shelf life. So if you're looking at a certain demographic in an age bracket, after, for example, 2 years, the people that was in that age bracket have now gone out of it, and new people are in it. So the old surveys are no longer valid. So how could we fix this, or at least mitigate some of the problems? Well, there have been a lot of new advancements in large language models, and these large language models are trained on a lot of text. they have seen a lot of examples where the different questions have been answered. And in the weights in these models, there's a lot of information which we can then maybe use to simulate a demographic and find similar feedback as if we would ask a real demographic. There's very little literature on this exact problem and trying to solve it. And we are trying to make a system that is using these large language models and can then just automatically, when given a survey, solve those surveys and get good results from it. So our solution is called synthetic personas. These synthetic personas is large language models. They are conditioned with specific demographic attributes. This means that we are trying to simulate in text a description of a person. And we are hoping that these large language models can use this description to color the choices they make on different questions we ask. And we are not interested in a specific person, we're interested in a group. And therefore we use the genetic algorithms to pick a group of these synthetic personas. And what we hope to get out of it is a system that we can get rapid feedback on asking questions, and then we can ask follow-up questions and dig deeper into the interesting bits. So we're interested in a group of personas, but how do we construct one personas? So this is an example where we try to construct the personas. Since I'm from Norway and the dataset I'm working with is from Norway, the personas we construct is focusing on that location. So we take a region in Norway, for example, and assign it randomly to these personas. Then we assign some gender to them, and based on the gender, we give them some popular names from Norway, and then give them a random age. We find this person a job, give it an occupation. We give him some different interests, such as different movies and books the person have read. And then write a bit about if the person is married, if the person trains, and what hobbies they have. They like different things like cycling and so forth. And lastly, we also take some inspiration from psychology and use the ocean model or the Big Five model. And when we're using this model, we generate the traits that are somewhat moderate. You can get the values that are kind of outside this range, but that we have weighted it so it's more rare. So it's more common to get moderate levels on one synthetic personas. So how does this look like in practice? Well, I have a synthetic persona here for you. So the name of this persona is Emma Pettersen. She is a 39-year-old chef that lives in Oslo, which is the capital of Norway. And she has an education level of bachelor degrees and an income of low medium. And we're hoping that this will shape how she answers questions. So since she's living in the capital, for example, if you ask a question about transportation, she is not that likely to own her own car since she's living so central and can take public transportation each day instead, for example. Okay, so how do you make our system? So as I said, we're not that interested in the single synthetic personas, but rather having a good group that can represent a demographic. So what we do in the start is that we generate a lot of synthetic personas, and we want to generate a large number of them. But the problem is that the more synthetic personas we generate, the more computational power this system needs. Because if you have, for example, 1,000 synthetic personas, and they answer a survey on 100 questions, we will get 100,000 answers. So this grows very rapidly in computational power you need for this system. So the more you have, the better answers you will get eventually when you run it through the system, but it will also cost you more computational power. You also need a survey that has been answered by your target demographic, because you want these synthetic personas to answer the survey, and you want to have something to compare to know if the synthetic group you are making is good or not. And then we take these synthetic answers and the real answers and use them together with the genetic algorithm to create an optimal group that is answering quite closely to the real group. And when you have this best group, you can then ask it on hidden questions to be sure that it can answer even unseen questions that you have not asked it yet. All right. So a synthetic personas will typically answer a questionnaire that looks something like this. So here we have a profile of a synthetic persona, and then we have some different answers that this synthetic persona have given. So this persona is also living in an urban location, so it makes sense that they're using public transportation a lot. And you will get a lot of these answers to different surveys, and eventually you will have, like, if you have 1,000 synthetic persona in the start, you will get 1,000 answers or 1,000 answered surveys in the end. But you're not looking for like this supergroup of synthetic personas. You want a specified group that represent the target demographic you're looking for. So what you do is you start with this supergroup, and then you create some initial groups. And these groups are created in the start, totally random. So you just pick some synthetic personas from the supergroup and fill into these subgroups. And then you want to evaluate each of the subgroups on how good they respond to your questionnaire. So what you do is that you take each of the answers that the group members have given on a question, and then from there you can, for example, build up a distribution that looks somewhat like the real distribution. So for example, we have some samples of synthetic personas, which is just for show, that we'll see that, okay, this synthetic persona on the first question has answered A, this personas on the second question have answered B. And by combining all these together and aggregating them, we'll get this distribution that you can see on the right side. So this distribution might not match perfectly up with the real distribution. And what we are doing is to try to evaluate how well the distribution for the synthetic personas and the real personas match up in reality. So what you're seeing here is that an example where on question option A, 40% of the synthetic personas answered A, while only 30% of the real humans answered the option A. So you'll see that we have a difference about 10% between the actual answers and what our synthetic persona system would answer. And we tally up all the options and we find all the difference. And the goal is to minimize this difference between the synthetic group and the real world distribution. So you do this for all the questions, not only one of them. And eventually we will get an average on how accurate these systems are at answering questions as it would be a real demographic. Then you take the different groups and you use something called a tournament selection. In these selections, you take the groups that score the best and you give them an advantage. And the idea is that the best groups will be selected and you will use these groups as a basis for forming a new generation of groups. And the idea of the genetic algorithm is that through generations of selecting better and better groups, you will end up with a supergroup that is very good at doing what you want. So you have found two parent groups and you want to create the new generation of groups. So how do you do that? Well, in our system, it's quite simple. You have, for example, parent group 1 and parent group 2. And what you do, you will take some of the synthetic personas from parent group 1 and keep it. And then you replace the rest of them from parent group 2. So you can see the first two from parent group 1 is kept in the child group, while the remaining is collected from parent group 2. And it's the reverse for the other child. So what you will have is that after this event has gone through, you will have a new generation that is the same size as the old generation. But because of how the genetic algorithm is optimizing for better and better results, these new generations will often score better than the old one. We also allow for some mutation of the groups, where you introduce a new synthetic persona from our supergroup. And over several generations, the accuracy of the groups will be better and better, which means that they will answer more and more like if you had gone out and did the survey to real people. And hopefully what you end up with is a system where you can ask a question and propose the different options, and then just click a button and get a very accurate response to that question. So you know what the things interest that specific group, and then you can ask iterative questions. So we did some experiments on this method, and I will talk a bit about what models and datasets. So this is part of some of my older research and ongoing research. So if you see it, we use the ChatGPT 3.5 API. At the time, I had some limitation in compute, but the field of AI is moving very rapidly. So right now, you can probably do it with local models, and we have done some testing, and you're thinking, maybe you can get better results if I'm using a newer model, and that is 100% correct. So we have tested newer and more powerful models give a lot better results. So the better the model is, the better results you will get. For the datasets, we have used what is called the General Societal Survey, which is a global survey, where they get a lot of answers from different countries, and we have focused on the Norwegian answers in this dataset. Also, Norway has the Central Bureau of Statistics, which we are collecting data from and comparing for different experiments. So we wanted to figure out how good would a person to do this task. So instead of asking 100 persons what they think about this subject, you asked instead one person, what do you think the group will answer to these questions? And how we did it, we have an example here. So in the example, we pulled from a database called the Family Feud dataset, which, if you have seen it, is a game show where you're trying to actually just guess what other people are thinking about. So this fits our task perfectly. For example, name a command a dog knows, but you wouldn't bother giving to your cat. And this is an example where I tried it, and it is surprisingly difficult. So I failed on this task, but when we gave it to different participants, they get different questions each time, and we take the average accuracy. And what is interesting is that humans seem to be about 63.5% accurate on average on these tasks. And it didn't seem like there was too much variation. So some people got some percentage over and under, but it wasn't like someone was super good at it and someone was bad. People was about the same level of good at it. And we also got our system to be better than the human baseline at this task. Okay. So one of the things we were thinking a lot about when doing these experiments was how we would structure and create this representation of real people. And would it even matter what we put in? So we looked into the different attributes, and we kind of tested how, if we change one attribute, how would the answers change? So we made a test where we made 4 groups. Each group had 200 synthetic personas. All the attributes were randomized, except for the age. So in one of the group, you get an age between 18 and 29. In the next group, it's 30 and 49, and so forth. So the idea here was that we checked some papers, and we tried to find certain things that would kind of be different between these groups and how they would answer to questions. And what we focused on was, because we found some papers that was talking about elderly and older people had a slower adoption rate of new technology. So they wasn't as fast to adopt new technology as the younger generations. This might change in the recent year and the coming years, but it's at least what the paper said. And when we made these groups and asked these types of questions to the synthetic personas, what we saw is that the synthetic personas is actually able to answer in a way that we expect from these type of groups. So as you can see on the right side, this is a question about how frequent are you online or on the internet? Young people are always on the internet every day. When you get a bit older, sometimes you're several times a week, but they are quite often. And the oldest people, they're not as often as online. Here are some other examples. For example, do you prefer calling or messaging? So what we know is that young people are using a lot more messaging apps, such as WhatsApp, Discord, Zoom, e-posts, and so forth, rather than calling. But the older generations prefer much more to call people. And we see that if you give the synthetic personas a higher age, they will actually prefer more to do phone calls rather than instant messaging. And same with how they want to watch movies and show. The younger generation is a lot on online streaming services, while the older generation is much more interested in traditional broadcast or cable TV. So we had a question when we was working with this, is that when we run the genetic algorithm, we see that on the training questions, it gets very good, very fast, and that is to be expected from the genetic algorithm. But the real question is if it actually generalizes a bit on unseen or hidden questions. And this on the right side is not just one run, it's because the genetic algorithm has some randomness. We have run this many, many times and taken the average. And we see that each time we run it, we get the better scoring results in the final group on hidden questions. So we will see if we run the algorithm, it starts out being a bit below the human average and end up above the human average. In the work I'm working on currently, that is taking this further with the better models, we have even higher scores than this. Okay. So in this experiment, we asked 20 questions and have had 5 of them hidden. And we tested different ways of distributing these questions, so forth, to see if there was like certain topics it was worse on and certain topics was better on. Well, it seems like this method of going forward with genetic algorithms always makes it produce a new grouping that is better than the last one. So one of the interesting facts we noticed when training and optimizing to answer better on questions was that the attributes we have given the models that was initially random seems to align more and more with the real demographic. And this is quite interesting because when we run the experiments, we don't directly train it to get this alignment, but it's something that happens more or less spontaneously during the optimization process. This is something we want to look into further, but we see that the income brackets, for example, in the right graph, is becoming closer and closer to the real income brackets of the demographic we are trying to emulate. So this is quite interesting if we can go from seeing if you can emulate the questions to see if we can emulate attributes of the population. This research has some types of limitations. One of the limitations is how we represent the different synthetic personas, because right now we're using a textual description and we are missing a lot of the nuance in the human life. So we can't represent a person perfectly with this way of representing it with just a text description. So we are trying to figure out if there's some different ways of representing a person. Also, a lot of the surveys we were testing on was on one, focused on one domain. So that means that, for example, if you have a questionnaire that is very focused on technology, and you get very good response if you ask technology questions. I'm not so sure if you get good responses if you start asking questions about health, politics, and regions to the same groups. Also, there's some challenges because we're using large language models in the bottom of our system. And that means that the underlying structure and the training data and the biases in the large language model will affect our results. So it seemed to work very good on the Norwegian population, but maybe for a population that doesn't have that much representation, this system might work less good. We haven't tested this yet, and that's something we want to look into. Large language models is also prone to hallucinations, and this is something we have to look into if we can improve the systems to handle these settings. So we are working on new research into this field, and there are different things we want to focus on, such as, is there a different way of representing personas? Can we use an embedding of a vector representation of it to capture the nuances in a human life? Or could we explore these different representations to create even better populations? Is there different ways of setting up this fitness function that we are using? But one of the things we have found was that how you ask a question affects a lot of how you get the answer. This is somewhat true for humans also. If you ask a question a slightly different way, you will get different answers. But we noticed that these models were typically, if you just switch the order of the options, you could so often get different answers. And we are working to find some way of making this system more robust. We're also looking into adding multimodal functionality, where you, instead of just putting in text, you can also put in images. And this is good for marketing because then you can ask something about a clothing piece. You can just show 2 images to know the preference instead of trying to make a text description of everything. So we're also looking at new models and so forth. So what can we use this technology for? Well, we can use it for a lot of things. Right now, in this research, it's close to 70% accurate, which needs some improvements to be very reliable. But you can use it as a first stage research on your products. So if you want to get some answers fast and kind of use it to develop the final survey you actually send to the human beings, this is a great way because you can kind of tune into what are the important questions to get 100% right and what are the questions that you don't need to be as accurate with. And I believe that there's a lot of interesting things to this research because this is kind of like a stepping stone where this is kind of the first stage. And I believe these systems will get better and better. At some point, I think people will be using systems like this a lot to do, instead of asking real people, they will use these large language models as a way to do market research. Thank you for your time. And if you have any questions,